everyone, and welcome to this educational session on Project Haystack. So the reason that I, as a native German, can speak so easily to you guys in English is because many, many years ago, decades ago, some of the biggest countries in the world have decided, let's make English the language that we all talk with. And it makes collaboration and communication so much easier. Now, if you apply this to the building market, today we see still that within buildings, there's lots of different languages, different protocols, different semantic models. And we at Project Haystack, we aim at harmonizing this. We aim at creating that common language that you can speak within the building, the different systems can speak, but also across buildings can speak so that you can really make use of the data in the best possible way. So before we get started, let's just quickly introduce ourselves. My name is Alex. I'm the CEO of Jade Innovations. We are a California-based company, and we fully utilize also Project Haystack. We're also a founding member of the data standard. And since the beginning of this year, I'm also co-executive director of Project Haystack, together with Richard.
Yeah, thanks, Alex. My name is Richard McElhaney. I'm the Vice President of Technology at a company based in Melbourne, Australia called Conservative. Our main thing is chiller plane optimization, but we work in this space very much. So a lot of data, a lot of plant meetings data, and we too have been a founding member of the Project Haystack board of directors, and very much involved in the development of standard semantic modeling. And looking forward to having a great conversation this afternoon.
Okay, perfect. So let's get started with the first slide. You put it to click. So let's look at a building, at one building. You see in a building lots of different disciplines, lots of different systems, and they all have their own protocols and semantic models. And that number is actually increasing. So traditionally you had an HVAC system, a lighting system, and you had some ancillaries, but now you also have smart sensing. You have more and more energy management, metering on the floor level, the room level, the building level. And so all these different systems, unfortunately today, because of the different protocols and semantic models, they have a very hard time to speak to each other. And that comes along with a big challenge, because if they would speak to each other, they could create so much more value of the data. So I give you a very easy example. You have an access control system, and that can tell you how many people have entered the building and left the building. And if that data was derived and given to an HVAC system, that HVAC system could act differently and say, okay, I might tune down my fan now because the building is getting empty, and why do I now need to run at full steam the HVAC system despite the scheduler telling me that? So you see the disciplines could way better work with each other, but currently they don't that much. That's the first challenge. The second one is these protocols have traditionally been built from automation system perspective. They have been built in the so-called OT, operational technology, and that makes it very cumbersome and hard to bring those data into the cloud, to bring it into higher value applications and services that can utilize it. And we've seen here also at AHR, many companies now provide applications in energy management, enterprise fleet management, and so on. But for that to be done, you need to bring somehow those data from the automation systems up in the cloud. And traditional protocols are not very good in this. The data models don't give you that capability. So that's the second shortcoming.
I think one way to think of this is it's not just interoperability of protocols, it's data interoperability, making the data be able to work with each other. Many of us have worked in building automation, Many of us have worked in building automation for a long time and used a lot of protocols, integrate. That's fine to make devices and equipment talk locally. We're talking about data interoperability, data being consumed by machines and doing things with that. And that's a different type of interoperability.
Good. Now let's move out of the building. You need to go to the next one. Now, okay. So that's true for one building, but it even becomes more severe if you look at multiple buildings. We are aiming at centralizing more and more applications and services. More and more, you don't want to look at just one building. If it's a very big building, it makes sense, right? In the airport, the facility manager can dedicate his time to that building. But if it's a smaller building, you want to compare buildings. You want to manage from one place different types of buildings. And now if all these different buildings speak different protocols and have different semantic models in place, how are you going to do that efficiently? So that's the second biggest challenge. That is very cumbersome to do. Now, the next one, if you go to the next slide, the next one is automation systems have been built so that devices and systems can speak to each other on very dedicated use cases. You have, for example, a sensor, and the sensor's purpose is to give you, for example, the outside temperature, and the automation system exactly knows what that sensor gives the automation system for that use case. But now you start to bring hundreds of thousands of different sensors into one common data lake to do big data analysis, to make sense of the data. Now it's not enough anymore to just say that's the NEMO sensor X, Y, Z. And now you need to know, okay, that sensor, where is it in the building? In which building is it actually in? What position in the building does it have? It doesn't make a difference if the outside temperature sensor is on the 25th floor, on the first floor. It makes a difference if it's on the north side of the building, on the south side, the west side, the east side. So making more sense of data is incredibly important if you want to build these higher value applications, because only with the information that's given traditionally by automation systems and protocols like BACnet, you won't be able from above to make those judgments. So you see there's a lot of challenges, and if you continue, I would sum it up and say overall the challenges within a building, but beyond buildings, you have that problem of interoperability and comparability. And you have the challenge that the data resides in an OT environment and it needs to now start to speak to the IT environment, to cloud applications. And that's what we need to tackle. We need to tackle this to derive different values, to save more energy. How can you save more energy? By making more sense of data. To centralize services, you need to do that. So you have one central place, for example, for all the buildings. You want to see the data in one central place. Therefore, it's relevant. And the third one is also higher asset efficiency. If I have more information on the asset, I can make more sense of it. So overall, that's the challenge. And this challenge is not one that's only a year old, I guess, but it's 15, 20 years old. And so Project Haystack had started many years ago to start to tackle that challenge. And that's what challenge up.
And that's the, I guess, one of the core reasons we exist is to tackle this challenge. And so some of you may not have gone deep on Project Haystack. So what is Project Haystack? So what is Project Haystack? And so I can summarize it with this phrase here: a standardized approach to make data versus the easy work with. It's a whole lot of words in a small space. But that's what we do. Okay. And the standard we have, the technology we have, the ecosystem we have actually delivers on all of this today. So let's have a look. So what are we addressing? We're addressing the challenge that Alex just laid out for us. Project Haystack is an open source community. What does that mean? The technology is available. It's there online. You can download it. You can use it. You can build your own applications. You don't have to pay money for it. Okay? The technology is there. There are companies. Our companies use it. So we have applications. You pay us for our applications, of course. But if you really want to build your own applications, the technology exists today. So it's an open source methodology for describing the meaning of data. So we have data. What we do is we add data to the data. So metadata. And we do this using things like called tags, and you go to tagging. Who uses Gmail? Anyone use Gmail here? If you tag an email, you're now doing semantic modeling. Congratulations. Well done. Welcome to the 21st century. So we use tags to describe data and to build models out of the data buildings. We put all this together, and now except we want to create applications to derive value off that. And so what this does is it makes it much easier and more cost-effective to work with data. Humans are really bad at working with data. It's slow, it's cumbersome. So what we want to do is have a system that makes it fast, where machines can consume data in a way where they both understand what's happening. And we want to think of this as a markup language. Okay? One of the most famous markup languages around, HTML, hypertext markup language. Project Haystack is a markup language for data in your building. So it could be a markup language for data from anywhere, to be honest, but we focus on buildings. Put your hand up if you don't use a web browser. I was hoping to catch someone out there. That's close. So this is one of the analogies we like to draw here. Okay, why can I point my web browser at your website and it will load and read what's published there? How is that possible? I didn't go and speak to you beforehand and organise what language it was going to be in, or how it was going to be rendered, or what code you might write it in. No, it was agreed what format the page will be transferred to my computer, and my browser now understands how to render it, how to show that. So because we agreed beforehand on the language, the markup language, everyone knows how to load a website. Everyone can read a website. It's exactly the same with data from your buildings. We need to know how to work. I need to know that when I read the data out of your building, what format is it in? How do I interpret that data? What meaning is attached to all of that? And that's exactly what Haystack does. And a whole lot more, but for devices, for equipment, for mechanical equipment, for lighting, for electrical, and a whole lot of other systems you typically find in your buildings. So that's what Project Haystack addresses. It's this challenge of being able to talk to each other and understand what we're saying. So semantic tagging enables this data interoperability that we're talking about. And these systems can be diverse. And many of us here at this expo are worried about mechanical systems and air conditioning and things like that's typically what we find here. There are many other places where we want this data to be tagged and have the models built up so that we can work with them. And there's some applications here, things like graphics and reporting, analytics, integration with workflow and maintenance systems, where these are all very useful applications, and tagging enables them to be delivered efficiently at scale. And so we introduced things in Project Haystack, in the technology, called vocabulary, taxonomy, ontology. There's some big words there that we're going to talk a little bit about in a minute. But very briefly, the vocabulary is a standard of terms that are just describe the data, and so these are our tags. Okay? It's the meaning behind it. The taxonomy defines relationships with hierarchy. Okay, so we can say something is this or is that, and it's and how it relates to other things. And ontology then expresses relationships between things. It could be a relationship between an air handler and the space that it serves. It could be a relationship between a power meter and the chiller that the power meter is connected to. So we can start to then express relationships between things at scale and work with that data very easily. So this is really what it boils down to, is that by utilizing semantic tagging, we can work effectively, efficiently with operational data at scale. And as I said, this isn't just about one building or one big building. This is about all the buildings. How do we deliver this? How do we work with data at that scale? So in the last couple of years, Project Haystack has been working very, very hard. There's particular people here in the room who've been doing a lot of work on this, and we released, as a community, we released Haystack for a fourth version of our semantic modeling technology. I say technology because it's not just a standard, it's a suite of things that come together to build a complete technology. And so this was a collaborative effort led by a number of people in the community, and it's really focused on formalizing the Haystack standard. Previous iterations of it were a lot more flexible and extensible. Some of the definitions weren't perhaps quite as clear-cut and as tight as we would have liked. So Haystack 4 really takes the modeling technology, the standards, the vocabulary, the taxonomy, the ontology, and puts all of this very clearly in a really structured way that formalizes all of these things. It's still a very flexible technology. It's still extensible. You can still add your own tags for those people who are sort of familiar with that thing. We don't frown upon those sorts of things. But by developing the taxonomy and the ontology that supports all of these that supports the vocabulary that we have, then we can really start to express very complex models, whether it's modeling the inside of a chiller or an air handler, or systems in a building, how the air flows and the water flows through a building. Very complicated things. And as we all know, no two buildings are the same. This is the challenge. If every building was the same, that'd be great. We just have one model, and we wouldn't be worrying about this. Every building is different. Every building has some peculiarities. It has a different shape, a different height, a different width. It can handle more people. It has might be a data center, might have a different cooling load. So we need to address this, and that's what Project Haystack does. And for those who understand what we're talking about, RDF, it's technology we'll talk a little bit more about later on in the presentation, but we do support working with W3C, so internet-based things as well.
Who knows what RDF is? Anyone has heard about it? Okay. Just want to get a pulse check.
You expect Scott to. So Haystack is more than just a data model. It is a complete suite of technologies to do absolutely everything we need in the space of semantic modeling, building models to deliver value on the application. applications. Initially, Project Haystack was just a data model. Right in the beginning, we have a history lesson coming up about Project Haystack for those who are interested. So it was just a data model. But the thing is, the data model is, not everyone sees that data model. It kind of sits behind things, it sits in the tooling, it's not always there. Over the years, the Project Haystack community, because of the open source nature of what we do, has collaboratively worked together to produce APIs, drivers, software libraries, engineering tools. Some you can buy, some are just there ready to be downloaded and used. And so we now have this complete stack of technologies that people can see and use system integrated. They touch it. If you work with certain technologies, you work with Haystack from Alex's company, if you work with Niagara from Tritium and other ones, SkySpark from different companies, they have all of these tools built in them. You can see them. It's not just a model they're sitting behind and not working with it. So just to
highlight on this thing, that's really, I know that many people start to compare different data models. And first of all, I think there's a necessity for different data models for different use cases. I don't think we need I think it was said, ontology wars. What data model is going to survive? We believe that there will be a few data models that make the race. That's important to us. But if you want to compare it and see where the different values come from, certainly Haystack hasn't come from the big data community originally. It has come from the integrator community and trying to make sense of data in an easy way, in a practical way, so that you and your projects can apply it. And that's also why we have 75 to 100,000 buildings by now out there that use Project Haystack through different companies that have embraced it. And clearly, we don't look just at the data model out of it. If you look, for example, at Magnet, many even call Magnet a data model. In fact, of course, there's data model behind, but you call it a connector, you call it a driver. So Project Haystack is also that. You have the full API suite, and so you can utilize the data model beyond just taking it into a Sparkle engine and running data to make analytics, but also to normalize in order to bring one device together with another device to better talk to each other and gain efficiency. So I think that's important for us, that we are, and we always want to be somehow the practitioners data, but at the same time, and we'll talk later about RDF, there is some things at the horizon that big data requires, and we also want to, of course, make sure that we tackle those requirements as well on top of that.
And I think the best thing about, particularly about the APIs, they're documented on the website. They're open standard. You can read them, you can download tools that support that, or you can just go and write it yourself if you really want. So again, it's open source technology with all of the facets that are required to deliver value out of all of these different applications that we're looking at. So just a brief history of Project Haystack. We have been around quite a while. We celebrated our 10th year back in 2021, it's a couple of years ago now. We did start in 2011. The open source project started back in 2011, and that was when I first started to get involved with it, doing a few different things. In 2012, we decided that some people who had been involved with Haystack decided that we really needed a form of governance over how we were going to do this. And we wanted to do certain things. We wanted to have in-person events and produce magazines and all these sorts of things to tell people about what we were doing. So we founded a 501c non-profit corporation and got a board that runs that. So there's a governance model behind Project Haystack that helps run events and do different things. In 2013, we was at Chattanooga, Tennessee. We had our first Haystack Connect event, and that was a lot of fun. It was a great place. It was nice and cold, and it was good down there. But throughout the years, we have continuously held events, whether it was Chattanooga or San Diego or down in Florida. We have had a number of in-person events over the years, and that's been a great way to bring our community together and teach people and learn from each other what's happening. We have also published a number of magazines over the years. The first one was in 2015, Haystack Connections. We published one towards the end of last year, and we're currently working on our next release of our magazine. It comes out twice a year. And if you go to the Project Haystack website, all of the magazines are available. And it's really great reading to see over the years how this technology, this part of the industry has evolved. There's a lot of history in there, there's a lot of great articles from people. And really demonstrates just how far we've all come in delivering these kinds of technologies. In 2021, we actually had our first virtual event due to obviously the pandemic and some of the restrictions that were placed on all of us during that time. So it was an incredibly successful event. So successful, we had one following year, 2022. And all of this is online. So we had a great event last year and a number of follow-up webinars, and we get great content from our community. And I think that's an important thing as well. We're not driven by a corporate agenda. We're not driven by funding from certain areas. We are driven by the needs of the community, the practitioners that Alex referred to, people who actually use this day in, day out. That's who drives us. Whether we're setting up events, whether we're doing magazines or producing other things, it's a community-based organisation, and everyone contributes to that and helps make all of this a success. And lastly, it's not actually probably history, it's the future, but Haystack Connect 2023 in-person event is back. We'll talk more about that. I'm looking forward to getting down to Nashville for that one in June. So who are we? So we keep talking about this board and founding members, and these are the companies that make up the board of directors for Project Haystack. The variety of companies coming from different parts of the industry, and it's been a great pleasure to work with representatives from these companies. We also have an associate membership base as well, and I think one of the things to highlight about our associate members is that they come from all over the world, and they all do slightly different things. It's not like they're all just BAS system integrators, or they're not all data analytics people. There are all sorts of skills and businesses that are involved with Project Haystack, and it's a global organisation, whether it's from Europe, from North America, from Australia. We actually have, I think we punch above our weight. We've got quite a few companies from Australia that are involved in Project Haystack. So, or even through Asia, there are companies all over the place that are involved. It truly is a global organisation, and I think even if you look at the forum, we have a forum where people post. I think we have around 1,500 people who have registered on that forum as well. So again, from all over the world, there is a lot of people involved in this, and you can see some of the activity and conversations when you go and have a look on that website. This is you.
Yes. So we yesterday we discussed. We had these standard slides that we can apply, and we thought, who can best talk about Haystack in practice? So then Scott volunteered actually to do that, because he's always good in presenting it this way. So Scott, you former founding member and board member of Haystack, and now emeritus, I guess you say in English, emeritus board member.
So that's how to translate the old guy that's been around the block once.
Exactly. Okay.
Sure. So I guess I'd like to see who's in the audience that's maybe a system integrator. And raise your hands. Okay. Just kind of get a feel for the use cases. How about building owners? Any building owners? And how about OEMs? OEM partners? A couple. Very good. Okay. So I think one of the things I realized early on in my career with Project Haystack is, what is the real world value? What is the use cases that might be applicable? We talked about a great history lesson. We talked about the big picture. One of the things that I like to talk about is, how does that impact a system integrator? How does that impact a building owner or a prospective OEM that wants to use Project Haystack? And I really came back to some basic use cases that we can all appreciate. And so I grew up being a system integrator. I clicked the mouse probably 100 million times when I created projects. And in a typical project, one of my jobs was to create a graphic screen, a summary either for the technician level or for the end user. And as you probably know, you look at the points coming back from the field bus, and you look at the name, like supplier, temperature might be SAT. And as a human, you're in the middle trying to decide where that goes on the graphic. Well, if we added just a little bit of meaning, as Richard said, the metadata to that point, and instead of just using the name, we now have some standard tags, some vocabulary, and perhaps it has discharge, air, and temp as the tags. Why does that mean anything? Well, if I was, let's say, creating this graphic and I wanted to teach a computer to do it for me, I would say to the computer, go look at where I'm focused. I'm focused on VAB1, read its points, and look at the tags on each one of those points. And if you see discharge, air, temp, and sensor, go ahead and grab a little icon that looks like a discharge sensor. Go and look for some other tags, like, do I have any history? So there is a history tag on points as well. And if I do, put a little history icon next to it. And then if it's a commandable point versus, let's say, an input for a sensor, go ahead and put like a little command icon right there. And so those are all decisions that I would have made as an application engineer engineering this graphic That's impossible today in software. An app can be taught once to do that. And all that extra work that I used to do, all those mouse clicks to create that user experience is now automated. That's a real practical system integrator labor savings example. Go to the next one. The next is those relationships. What is the hierarchy? What is the connection between some of these points? As we know, as mechanical engineers or as building owners, VAVs are downstream or have a relationship to an air handler, the ductwork, primary, secondary system. What if we could represent those relationships in tags? So in the standard, there's a thing called a reference tag. And so in reality, it's AHU ref. And so what if I wanted to teach software to build a little spreadsheet of all the air handler VAVs and put that on a screen? Well, we would basically say, get our context, which is air handler 1, go look for an AHU ref tag, and pull up all the results that match the context, which is air handler 1. So this graphic literally can be dynamically generated if we're using metadata, if we're using software or applications that utilize metadata to make those kinds of inquiries and to generate those kinds of results. So another great example of perhaps an OEM who's building a piece of equipment and he wants to see all the hot water coils that are downstream of the boiler system. If you use Project Haystack and you connect it to a system that's been tagged, you can get that kind of query and that kind of output dynamically. Next slide. And then finally, one of the biggest pain points that we all have, both as end users, looking at the graphics and realizing that the point is really not connected to the right sensor, is all the labor that goes into the user experience. And here's an example of an equipment graphic. Every one of these labels and every one of these little widgets is tied back to a real point in the system. Back in the day, if I'm doing BACnet or LongWorks, I'm literally dragging and dropping a point as an application engineer. I'm looking at the screen as an end user of all those relationships that were handmade to this graphic. So what if we took that same concept of those tags, and we made all the linking back to the user experience dynamic? Because we know that this is a discharge air sensor. So if we look for tags that have discharge air, temp, and sensor on them, then this air handler could dynamically link to that. And so this error-prone user experience becomes totally perfect because the computer is able to figure out those tags and match them up with all the right points. Another good example. And then finally, we're doing a similar thing for control or for analytics. What if we have a set of blocks, but instead of being used for visualizing things, these blocks are used for control, for making decisions, for analyzing. So same idea, we can take what we call a sequence of operation and add tags to it, and then have those tags dynamically linked to the control blocks. And in fact, this concept of relativizing things, where I have one set of blocks or one graphic, but it's used over and over again for multiple pieces of equipment, becomes a huge efficiency, both in resources and in engineering labor. That's where we might use tags for control. I only have one more example. Yeah. So instead of going to look at the real-time data, what if we now want to look at the historical data? We can put tags on historical records just like we do for real-time records. So here we might have an analytic, a rule that's trying to find out what's going on in the building, find some information about it. So we could take that rule and dynamically attach it to the tags, and we can even get that relativized effect of one to many. So we can make one rule and have it applied to 1,000 or 10,000 different VAV boxes, and then the resulting analytic summary would pop out of it. There's another good use case of where an application combined with tags can generate some really good outcomes. That's back.
Thank you, Scott. Thanks, Scott. Thank you. So, this course provides some real world use cases there. I think they're fantastic examples. Moving on, Project Haystack doesn't just sit on its own, it doesn't sit in isolation. We work with industry, we work with organizations, and we're very fortunate to have recently been the recipient of funding from the US Department of Energy to work on the further development of the semantic modeling standards. But this is in a slightly different way. One of the challenges that we have in producing these models is making them accurate, making them consistent across the buildings. Haystack 4 goes a long way in defining all these things. But who's checking? And the system integrators are on site and then deploying them. And we all make our best efforts to get these things right. Sometimes things might go wrong. So the benefit project, which was awarded to Project Haystack and has been conducted by 5 companies under our umbrella, aims to solve that problem so that we can actually move the state of the art forwards in our industry to ensure that when we are doing tagging, it's correct, it's validated, and we can prove that that it's being deployed properly. This is a big deal because then it makes the deployment of analytics easier, it makes the deployment of the graphics generation easier, it makes control routines, applying them using tags. If you can be sure that you have consistent, repeatable, and accurate tagging and deployment models, then we can really start to move the industry forward. So that's a really big win for Project Haystack. We're very proud to be involved with this and thankful for being able to deliver it. And that's work that's going on right now. There's code being written, people working on it, and that will be delivered over the next year and a half. So Haystack is also open source. So we have a long list of open source libraries. So if you go to Project Haystack.org, go to the downloads link, there's a lot of open source software libraries that are available. And the reason we do this is that people have different applications, different programming languages are required for different use cases. Whether you're in the cloud, you might use one set of technologies. If you go down to an embedded device, then you need a different set of technologies. And so our community is generously donated back to itself a whole raft of open source libraries that you can go and download, you can use them, you can build them yourself, you can contribute back to them. We always appreciate it when people contribute back. So you can go and see this right here now and see all the work that the community has put in. We do evolve the standard in a number of different ways. So we have what we call working groups. And working groups are started by people who are interested in one particular area. And they allow us to add, evolve, develop the standard in various areas. 3 recent ones where there's been some output, Haystack Labs working group, they look at developing some of the core modeling technologies. So they propose new tags, they might be proposing some additions to how we look at things. The EV charging working group is actively working on a proposal for including electric vehicle chargers. Tagging that, who would have thought? But with the advent of EV chargers coming into the built environment, this is now a system that we need to model. We need to interact with the data coming from these systems. So that draft has been published, and you can see that online. And for those who work with VRF technology, the VRF technology completed its work late last year and published a new chapter that now models VRF systems. Previously, this didn't exist. And so a few people got together and did that work, put in the effort, and published that. So now that's available for everyone to use as well. Circling back to what we said earlier, 3 little words. Are there any data scientists in the room? I'm not going to offend anyone, I don't think. If you are a data scientist or a data geek, you will be very interested in this. 3 letters, RDF, Resource Descriptor Framework. It is something that is important for the academic world, for the data scientists who work with big data. When I say big data, really, really big data. So the Resource Descriptor Framework is something that we're extending and developing into the Project Haystack standard. It is the way of the future when you're looking at analysis at academic level for big data. We've had a lot of feedback from the industry. This is one area where Alex and I and Scott and our colleagues who are on the board, we engage, we interact with the industry, and everyone has sort of come back to us and said, we need this in your standard. We need RDF technology. So that's coming along. And in 2023, we committed to improving our capabilities in this area to make it a first-class part of our standard. We'll have more to say on that throughout the year, so stay tuned on that one.
Yes. And so we do have RDF ready today in Haystack 4, but we are trying to make it first class. And that's to the big data community, to the data scientists. Not so many in the room today, I guess, but there are lots that need those, and for those we do it. So today, I hope you can see it on the slides, the light. So today we live a top-down approach in integration. You have the different silos in the building, and then you have integrators coming in that start to tag the different silos and normalize everything, create a common data model, and based on that common data model, you then start to build your applications for energy management, analytics, and so on. So that, of course, is because most buildings have been built. But to be fair, also, even today, when you buy an automation system, it's still in its silo to some extent. And so that is where we are today. And that requires a lot of work. It's still worth it, so don't get me wrong. It's already today worth to do that integration, normalization, and build the applications on top, but certainly it's more work than what it could be. And where we believe the market will go, and if you click once, we want this to become a bottom-up approach. So there's a few OEMs here today, automation companies, equipment companies. We believe that if equipment automation companies could not just have something like BugNet to speak the language of automation within the building, but also apply Project Haystack or other data models, compatibility northbound, then we wouldn't need all that integration anymore. Then those devices and systems could magically speak with each other. So if you remember at the beginning of the presentation, we all speak English together. Okay, for most of you, it's easier because that's how you were born, but it makes it so much easier for all of us to speak this way. And so we basically want everyone to be born with the English language, so we can so much easier communicate with each other without the work of the integrator. Now, with that theme in mind, if you click further, we at Project Haystack, we work a lot on giving the tools to the OEMs to do that. So certainly we have an ever-growing dictionary that we provide open source to the market. We have an openly available community. There's lots of companies also reaching out, for example, to myself or other people in the technical community, and everyone's willing to help. Even if companies are in competition to one another, it doesn't matter. We're all behind the same idea of collaborating. So that's a big part. And the third one is, if you go through, there's lots of open source SDKs. So if you want to build as an OEM your Project Haystack API in TypeScript for a bigger device or bigger system, or Rust for a smaller system like a thermostat, or if you even want to apply an entire database based in Project Haystack with Hexel, there's lots of open source tools available. So there's no excuses anymore for OEMs to go down that route. We make it very easy for you. And that's where we're really now putting the focus. We have a lot of members in our community, official members, associate members, founding members. We have lots of companies we work with also. And we really want to push you to make your systems compatible with Project Haystack from the very beginning, bottom up, and make the integrators' lives do that way easier.
If it all seems too hard, please come and talk to us.
Yes,
we will help you.
Exactly. So with that, we're kind of at the end of the presentation, and now we have. You already announced a little bit that the next event comes.
This is the fun part. So for those who are available, in June 5th to 7th this year, we're all heading down to Nashville, Tennessee. I've never been, so I'm kind of looking forward to it. And we'll have our first in-person event since the pandemic. Now, we've attended these in the past. We really like them. We get to engage with the whole community. It's very much a technical education conference. So if you are looking to understand how people are using this technology, if you're looking to learn about it, to hear the latest and greatest, and network and see products and solutions from companies like ours and a whole raft of others as well, then Nashville will be the place to be in early June.
And it's a lot of fun.
And it's a lot of fun. So what you get to meet Haystack practitioners. Not just us, but the whole community of people who come from around the world. Some are OEMs, system integrators, but thought leaders in this space as well. You will definitely do a lot of learning about Project Haystack down at our event. There are general sessions, there are breakout tracks from various people who are keen to contribute their knowledge back to the community and back to people like you here today to help, again, advance people in this space and help them learn about how they can get involved. And then you can get involved on the spot. People will help you. If you want to write some code, if you want to help write a new part of the standard, if you want to do trainings, we have a training program as well. You can get involved right there on the spot and start being part of the Project Haystack community. So how do you do that? You go to haystackconnect.org and you can register right now. We have early bird prices on, so that's going for a little while yet, but you can get an early bird price. You can also sponsor. So we have a trade show attached to the event. Our companies are sponsoring. There's people already signing up to sponsor. So come and join us if you have something to show or you'd like to be part of the community. Feel free to get online and register to sponsor as well. And the last one is to have fun. this is going to be a great event. It's our first in-person event for a few years, and we're having it in one of the best places to do this. You know, we'll all be heading out and getting to some music, I think.
Absolutely.
And so you can just go to our website and register on that. So www.haystackconnect.org. It'll tell you everything you need to know about the event, and if you have any questions, you can contact our team. So look, I think that brings us towards the end of our presentation. I think we're on time. But we really appreciate everyone attending. It's kind of the last hour of the first day, and everyone's been walking around and they're tired. So maybe it was good to come and get a seat for a few minutes. But we really appreciate everyone sticking around and listening to us. If anyone's got any questions they'd like to ask publicly, we're more than happy to answer them. We'll be here for a few more minutes as well if you'd like to come up and have a chat privately as well, and learn more about Project Haystack. So once again, thank you for your time, and enjoy the rest of the show.
Thank you.